Hello. The BC crew wants to say hi to someone,
Hey,
obviously.
Hi, Bella.
What's up, Mazuka?
Yeah.
Get ready. And Madel's here. She says, what's up? All right, let's get into this. It's pretty easy, I think, straightforward. We're going to start with sequences. So here it is. By the way, what's the difference between a sequence and a series? A sequence, we're talking specifically about the terms, while a series is a summation of those terms. Cool? Cool. So this one, the first example, it says, find the first 6 terms and the 100th terms of the sequence A of n, where... So this is called an explicit, like they tell us the sequence explicitly. Because we can find any term with this right here. Does that make sense? So you just go a of 1. A of 1 is negative 1 to the first power over 1 squared plus 1. By the way, all this is doing, the negative 1 to the n, all that is doing is every single term that happens next is just changing the sign. 1 is positive, 1 is negative. 1 is positive, 1 is negative. 1 is positive, 1 is negative. Does that make sense? So here we go. Negative 1 to the 1 power is negative 1. 1 squared is 1 plus 1 is 2, so negative half. That's my first sequence. So a of 2. Negative 1 squared over 2 squared plus 1. So negative 1 squared is going to be a positive. 2 squared is 4 plus 1 is 5. So 1/5. A3. Negative 1 to the third over 3 squared plus 1. So negative 1 over 10. A4 is negative 1 to the fourth over 4 squared plus 1. So positive 1 to the 17. A to the fifth. Negative A subscript 5, sorry. Negative 1 to the fifth over 5 squared plus 1. So negative 1 over 26. And then finally, a to the 6 is negative 1 to the 6th power over 6 squared plus 1. So that is 1 over 37. And they also want the 100th term. So let's do that really quick. A of 100, I think that's what it said, right? And the 100th term equals negative 1 to the power 100 over 100 squared plus 1. So a positive 1 over 100 squared, I want to say that's 10,000. So then 10,001. And there it is. Pretty simple, right, guys?
Yeah. Like a FRQ will say 5 terms.
Well, this is like the intro. We can't just go right into... It's like... I don't know, it's like telling a baby to go run a lap. Like, you can't even crawl or walk. Like, okay, I'll stop. Okay, so right now we're just learning about what it means. By the way, you can make the terms. You can do this if you wanted to. Negative half, comma 1/5, comma negative 1/10, comma 1/17, comma negative 1 over 26. Those are the first 1, 2, 3, 4, 5, 6 terms of your sequence, of the sequence. Cool? Okay, next one. Find the first 4 terms and the 8 terms for the sequence defined recursively by the following conditions. What does that mean, recursively? Context clues. Look at your cursive. You're funny, miss. All right, all it means is this, that you're saying that the next term is dependent on the previous term. And notice that on this one, we could find any term. None of them depends on any of them. We just find it immediately. Does that make sense? But recursively means that you're basing the next one off of the previous one. So this b of n minus 1 is your previous term, is the previous term right before it. Does that make sense, guys?
Let me write it down.
So that's what it means. So usually you state one of the terms, which is usually the first one. It doesn't have to be, but it's usually always the first one that they give you. And then the next one is like, okay, here's how you find the next term.
Because it's -1.
Yep. Yep. Is any of this kind of review, like from geometry or something? No? Okay. It's also an algebra teak, but because of the pandemic, or maybe because you guys went through the accelerated algebra, it's possible that they didn't even cover it. You know what I mean? Regular algebra? Okay, so maybe, so it should have maybe been in there towards the end, but that's fine. All right, so here we go. Find the first four terms and the eighth term. Well, they already gave me the first one. B of 1 is 4. B of 2 is, well, let's see, I take 4 and I'm going to add 2. So what's that? 6. B of 3, no, you're good. 8. B of 4, 10. That's it. By the way, how do we, I just kept doing this. The last term plus 2. So my last term was 4 and I went plus 2. Okay, now to get my third one, I go, my last term was 6 and I go plus 2. My last term was 8 and I go plus 2 because that's what this tells me. Does that make sense? Perfect. And then, is that all they wanted? And the eighth term. Okay, so let's take a guess. How do I find my eighth term? Well, according to this right here, it's my seventh term plus 2. Guys, check that out. Let's just do an easy definition. So my base of eighth is equal to the very first one plus, didn't I just go plus 2? Now, if I go to my eighth term and I'm already counting my first term, so that means I just got to go 7 more terms, right? So if I go plus 2, don't I just have to go 2 times 7? So there it is. So I'm going to go 2 times 7. Usually the book will say it like this. So it's going to say 8 minus 1 times 2. I think this is the typical definition, but whatever. I don't care. Because we're not robots. I'm not saying I don't care. I don't care. Understand the logic, and you'll never need to be robotic. I did 7 terms after the first one. Every term goes up by 2. 7 times 2. So that's 14. 14 plus 2. 14 plus 4. So there it is. How do we feel, guys? Okay. Awesome. All right. What we just did. Oh, what happened?
No, I saw that.
What we just did is called an arithmetic sequence. So every time there's just a difference of something and you're just adding or subtracting a number, it's an arithmetic sequence. And that's what this is saying. A sequence A of n is an arithmetic sequence if it can be written in the form of A plus D, A plus 2D, blah, 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 A, n minus 1. See, there's that definition, times D. Where this is how many terms have passed. After first, if that makes sense. No? Yeah, like this is my first term, right? So let's think. This is my second term. Notice there's a 2 there.
Oh.
This is my third term. Notice there's a 2 there. So 3 minus 1 is 2 because 2 terms have passed since the first one.
Oh.
If for the third one. Does that make sense? Okay. So check it out. For each of the following arithmetic sequences, so they're telling you they're arithmetic. Find letter A, the common difference, letter B, the ninth term, the letter C, the recursive rule for the nth term, and an explicit rule. So they want the recursive rule, and then can we make it in such a way that we can do it for any n? So let's see if we can figure it out, guys. You guys ready? Letter A, let's just do sequence 1. We'll start with a simple one. Don't worry, we're going to be okay. From -5 to -2, what did they do? Add 3. -2 to 1, did they keep up with that? Perfect. So for letter A, we're just going to say the difference between the successive terms is 3. The difference between successive terms is plus 3. How do we feel? Okay. Letter B. They want the ninth term. So look, let's not freak out. What letter do you want to use? A, B, doesn't matter to me. A? So A of 9, we're just going down the alphabet. So my ninth term for this sequence here is going to be my first term plus, what was the difference? 3. So I'm going to go, yeah. So 9 minus 1 times 3. I'm just using the definition, but let's not be robots. I'm just using their definition, by the way. Yeah, perfect. Yeah, I guess maybe I should have just stuck to my guns. So you guys are already pretty much pros. -5 plus, I did 8 more terms. So 8 times 3. So -5 plus 8 times 3 is 24. 8, 16, 20, right? Oh, yeah, 24. 24. So -5 plus 24 is that 19? There it is. My ninth term is 19. How do we feel? All right, here we go. Letter C. They want a recursive rule. That's simple. A's of 1 is going to be -5. A's of n is equal to, what am I going to write, guys? A's of n minus 1 plus, parenthesis, n minus 1, close it, times 3. There it is. And I guess I should make it a good habit here. For n greater than or equal to 2, where n is an integer, by the way. N is an integer. An integer? Well, if it's recursive, you can't, because in recursive, you always give the very first one. And then you say, how do you do the next? It's based off the previous one, plus you got to have a starting point. You know what I mean? Yeah. But for the next one, for letter D, it says an explicit rule for any D, for any n. It's really easy to do. Ready? Plug in this, which is what? So I'm going to write A's of n equals -5 plus n minus 1 times 3. I think that will work, but distribute that. So we can have a nice, clean -5. And then we'll test it, don't worry. Plus 3n minus 3. So -8 plus 3n. So let me rewrite it. A's of n equals -8 plus 3n. Let's see if it works. If n equals 1, -8 plus 3, -5. If n equals 2, 3 times 2 is 6, -8 plus 6, -2. If n equals 3, -8 plus 9, 1. Is that my sequence? Perfect. It works. We're good. How do we feel? All right, now let's do the harder one. But relax. It's not even, I say harder, but it's only because it's ln. And for whatever reason, kids are scared of ln's. All right. They already told you it's recursive. Chavez, how do you know it's recursive? I don't see that. 2, 6, 18. Guys, well, remember, this is summing. So let's find the difference between these two. Ln of 6 minus ln of 2. That's the same thing as ln 6 over 2. So that's ln of 3. So they're adding ln of 3. Do you guys see that? So let's see if it's true. From ln of 6 to ln of 18, is that plus ln of 3? Well, let's see. Ln of 6 plus ln of 3. Isn't when I add, don't I multiply the logarithms? What is 6 times 3? Yep, it works. I got 18. Let's do one more. Plus ln of 3. So 18 times 3, 54. It works. Cool or not cool? So letter A. What am I going to write? Perfect. Perfect. The difference between the successive terms. And you don't have to use the word successive, but I used it because that's what the textbooks and math people use. The difference between the successive terms is ln of 3. Done. No, well, they just want the, like, what was the that we were adding? We were adding ln of 3 over and over again. That makes sense, guys? All right, letter B, what do they want? Okay, so we state the first term because they want it in, they just want the ninth term. Okay, no big deal. So the ninth term, so a of 9 is equal to the very first term plus 8 times ln of 3. Does everyone know how I got those? Perfect. A of 1 was ln of 2. So let's see. A of 9 equals ln of 2 plus, and I'm kind of tempted to write it as ln of 3 to the 8th power. Is that okay with you guys? Okay. So then this must be ln of 2 times 3 to the 8th. And I could write it as a number, but I'm going to leave it like that. It's a big number. I don't know what that is. 3 to the 8th, 3 times 3, 9, 9 times 3. Yeah, it's going to be a big number, some big number. How do we feel? Okay. Are we ready for the next one? Letter C. Letter C is going to look similar to letter B. Letter C, so we're going to have 8th of 1 has to equal ln of 2. And then 8th of n has to be 8th of n minus 1, which is that ln of 2, plus, and then you're going to write n minus 1 times ln of 3. Come on in, come on in. Oh, now, did I do that right, guys? I don't know if I did it right. Yeah, ask.
Are all of them going to be adding like the patterns?
For this one, not always. If it's geometric, it's not. Oh, I did mess up. I might have messed up on this one over here too. Darn it. Isn't this one just the next one? Okay, this is the previous one. So I'm not, okay, so this is wrong. It's just plus ln 3. Because this is the previous one. We're only adding by ln of 3. So then that means I messed up on this one here too, on letter C, right? So that should not be n minus 1. That should be plus 3. I'm sorry, guys. Fix that mistake on your for the explicit one it would work. But for the implicit one, the explicit one it would work. But for the recursive one it would not. Does that make sense? Okay, sorry. So let me just make sure so we understand because I think we understand, but just in case. This one is talking about, this is the previous one, right? So all we got to do is just keep adding plus 3 to the previous one.
No, I get it.
Oh, okay, sorry.
And yours, this one. That's why I said plus 3. But...
Yeah, so I messed up. But this is correct for this one, but it's not correct for letter C. Okay, so we're good. So what we found is the answer for letter D. So here we go. Where, of course, on this one, n has to be greater than equal to 2. All right, letter D. That is the answer for letter D, guys. A's of n is equal to ln of 2 plus n minus 1 times ln of 3. That is that one. And if we want to make it pretty, here you go. A's of n equals this. Anytime there's a plus, remember, anytime there's a plus, I can write one ln as a product, right? Yeah. So ln 2 times, and then write it like this. 3 to the power n minus 1. What do you guys think? Hey, grab a taco. There's bean and cheese, there's potato egg, please. How do we feel, guys? All right. All right, let's keep going. So here's your answering your question, Viacana. Notice on this one we are not adding. On this one we are multiplying. And that is called a what? Yeah, well, to find certain stuff, yes. You guys ready? No, don't worry. Let's start with something basic. So look at this. So, yeah, they're telling us that it's a geometric. They're telling us. So we know these are geometric. We know for a fact. Okay? In the future, you're going to have to determine which one it is. So, 1 to negative 2. What are they multiplying by? Times negative 2. Let's see. Negative 2 times negative 2. Negative 2 times negative 2. Is that negative 4? Yep. 4 times negative 2. Is it negative 8? 8. Negative 8 times negative 2. Is it positive 16? We're good. So for letter A, this one says the common ratio. What's the common ratio? Yep. So I'm going to write the ratio between successive terms is negative 2. All right, let's talk. Let's see how we're going to figure it out. Ready? I want the A of 10, so the 10th term. So my very first term was 1, right? And then I have to multiply by what? Negative 2. But I have to do that how many times? To the 9th. Perfect. Yep. Good job. Do you see how we did it? And does everyone know why it's a 9 and not a 10? Because that 1 is your first term, and then to get to the 10th term, you got to multiply by negative 2 9 times. Perfect. And then, I don't know what negative 2 to the 9th is. It's some number. Let's see. 2 times 2, 4, 4 to 2, 8, times 2, 16, 32, 64, 128, 256, 512. 512. Negative 512. Are we okay? All right, here we go. Let's go to letter C. A recursive rule. Can we figure out a rule?
Yes.
Okay, well, for sure. Oh, recursive. So that means I got to give it something. I got to give it the first one. A of 1 has to be 1. And then A of n has to be what? We multiply everything by negative 2, right? So it's going to be A of n minus 1, put this in parentheses, times negative 2. And if you want to put the 1 in front of that, you can. But there it is. How do we feel? For n greater than equal to 2. Letter D. What do they want for letter D? An explicit rule. Oh, it's going to have to be the same thing. I think we can just go right off the bat. A's of n equals negative 2 A's of n minus 1. Oh, of A's of n. Let's see if it works. Let's see if it works. 1. Nope, it doesn't work. A of n. Yeah. I mean, I got the answer, but I don't want to look it up. But
N minus 1. That's what we did in D, right?
works perfect. Check it out. If I plug in a 1, 1 minus 1 is 0. Anything raised to the 0 is 1. If I plug in a 2, I get negative 2. If I plug in a 3, I get 4. If I plug in a 4, I get, man, miss, you're a genius. So there it is. There is my formula. Oh, no. Well, remember we multiplied every one by negative 2? So negative 2 is the key. So let's pretend like, okay, so what am I doing? Negative 2 what? Am I multiplying by something? Maybe. So if I did this, then I'm like, okay, does that make sense? Like a is a 1. Nope, it doesn't make sense because that 1, like, doesn't make any sense. Like how, like, you know what I mean? That one maybe you can use like for something like that. So then you're like, okay, so where does the n go or what? If I do that, well, if I put a 1, I get negative 2. But notice that at 1, I better not be negative 2. I better be, like, that will work, but that will work for all of them except 1. Well, actually, all of them will just be off, right, for the terms. So then you're like, okay, well, what about that? If you plug in a 1, do you get a 1? Yes. Does that make sense? So a lot of these times you just kind of have to like, okay, what can I do? And maybe it's going to be trial and error initially, trying to see what works and what doesn't work. That makes sense? You ready for the second one? All right. In case you are scared about this, just look at 1 and 10 here. What do you notice, guys? Times 10. So letter A, we're going to say the ratio between successive terms is 10. Grab some tacos. Letter B. A's of 10 is going to equal to, or the very first term. So 10 to the negative 2 times, and then I got to go how many more terms? So I'm going to multiply this by 10 to the, 10 to the 9th. Why? You already did the first one, and then every single term you're going times 10 times 10 times 10 times 10. So I'm going to do it 9 more times after the first one. So there it is. And then you just add up your exponents, laws of exponents. So that's 10 to the 7th. How do we feel, guys? All right, letter C. So letter C is recursive. So A of 1 is 10 to the negative 2. A of 1, I keep doing that. A's of n is equal to A's of n minus 1, which is at 10 to the negative 2. Times 10. And that's it. For n greater than or equal to 2. Sometimes they write, so when you go to delta, don't freak out, or when you see it on the AP exam, don't freak out. That 10 is usually written here in the front. But it's the same thing. You'd get it right anyways. Cool or not cool, guys? All right, letter D. A's of n. So help me out, Viacana. What is it going to be?
Anything, because we start at negative to the power of negative 2.
Okay, so let's start 10 to the power of negative 2. And then
we're going to do the, sorry, I'm ready to get that. The 10 to the power
Come on in.
of,
is it n or is it n minus 1?
n minus 1.
N minus 1, yeah. Now let's put it all together. If the n equals, add up the 10 to the power, remember we're adding exponents, right, when we multiply? So n minus 1 plus a negative 2, n minus, there you go. Will that work? Yes, it will. If I plug in a 1, I get a negative 2 in the top. If I plug in a 2, I get a negative 1 in the top. It works. Do you see how we're doing it, guys? Awesome. All right, now it's just practice. Don't worry, guys, we're almost done. And then we'll start with the AB stuff. Grab some tacos, enjoy some breakfast while you're at it. All right, example 5. It says the second and fifth terms of a geometric sequence are 6 and negative 48, respectively. Find the first term, the common ratio, and an explicit rule for the nth term. Oh man, Chavez, I don't know.
So we know 8 to the subscript of 5.
We know, all right, yeah, let's see what we know. So this negative 48, How did I get that? We got it by A1 times R to the 4th. R is my ratio. R stands for your... Well, because you told me earlier. You told me earlier, like, how do we do...
Oh, because it's a fixed term.
Yeah. Do you know what I mean?
Yes.
So that equals negative 48. All right. And then how do we get that 6 there? A1 times... the number 6, yeah. Which is that the second one? R to the 1. So can't we just do this? A1 R to the 4th over A1 R equals negative 48 over 6. Look what's going to happen here. The A1s cancel out, and this is going to be R cubed. Do you see how we did it? So what's negative 48 divided by 6? What is it? I think it's 8, but I'm not sure. 6, yeah. Negative 8. So then how do I find my ratio if R cubed is negative 8? Take the cube root. Take the cube root. R equals negative 2. There it is. That's how we find our ratio. And it's very common to use the letter R when you're finding it because it's ratio. Yeah. How do we feel? Okay, so we got that part. Find the first term. That's going to be easy now. Well, before you find the first term, we can do this. An explicit rule for the nth term. Now that we know A's of n. Now that we know R. No, I think we're going to have to figure out A1 first. Yeah, so don't worry. Look, we already know this one. It's easy to get it now. A's of 2 equals 6. What was my ratio? Negative 2. So all I got to do is just what? Well, I have to go backwards. So divide by negative 2. So what's 6 divided by negative 2? So that's my first term. How do we feel? All right, here we go. A's of n. Well, A's of 1 is negative 3. Do they want it recursively or explicit? Or both? Explicit rule for the... Okay, so just explicit. A's of n equals... My first term was negative 3. So negative 3. And then my ratio was what? Negative 2. So this is what I'm going to raise to the power. Because it's my... Like from the terms. So is it to the n or is it to the n minus 1? N minus 1. So let's check to see if it works, guys. We might need to... It might... Yeah, we might need to maybe... no, it might work right off the bat. Let's see. 1, negative 3. Perfect.
It gives the second one.
Oh, okay. No, it gives us the first one. 2, does it give us 6? 2 minus 1. 1, negative 3 times negative 2. Yeah, I think we're good. 3. Check it on this one. What was that? The fifth one? Check the 5. 5 minus 1 is 4. Negative 2 to the 4th power is a positive number. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times negative 3. Yeah, negative 48. It works. We're done. There it is. Cool or not cool? Grab some tacos, Martinez. All right. Find the 94th term. So this one, they're telling you it's an arithmetic sequence. There's the first, there's the second, there's the third. No, we're still adding. But you can subtract, though. You can subtract. So what is the difference between 25 and 31? 6. So you're going to go like this. A of 94 is equal to 25 plus what times 6? 93 times 6, no? And then whatever that number is, that's your 94th term. All right, example 7. Find the 11th term of the geometric. Okay, you guys know how to do that one now? Times negative 4. Okay. So A11 equals 10 times n minus 1 times negative 4. So, oh yeah, it's geometric. So we got to raise it to the power. So times negative 4 raised to the power 10, n minus 1. Because we did it 10 more times. And whatever that number is your answer. All right, last example. The first 3 terms of the sequence are given. Find the 6th term. They don't tell us if it's arithmetic or geometric, but we can tell real quick. It's probably geometric. Let's see. 48 divided by 16, what's that, 3? 48 times 3, is it 144? I feel like I'm going to say yes. All right, there it is. So then, if we want to find the 6th term, we're going to go a of 6 equals 16 times, and we already found it. We said times 3 was the ratio, right? 3 to the power 5. How do we feel about this? So do we feel like today we spent some good quality time? So we didn't waste anyone's time, right? Okay. All right, guys. So we have a Delta Math activity. It's over this, where you're just finding these. And that's not going to be under the algebra. It's not going to be under the calculus tab. It's actually under the algebra tab. But it's good experience. And once you finish that, I think you'll be beast when it comes to sequences. Next step, the next evolution. Now we're going to start talking about series, about the summation. So good job. We got the sequences out of the way. Was it a good intro?
Yeah.
All right, Mazuka. I hope you had fun. I hope you enjoyed it. Everyone is excited. So, way to go! Yay! All right. Talk to you later, Miss.